Hello and welcome students. We are working on indefinite integration. In indefinite integration, today we are going to solve problems using following results. Problems based on integration of f dash x upon f of x dx equals to log of mod f of x plus c. Integration of f dash x upon square root of f of x dx equals to 2 times square root of f of x plus c, and integration of f of x raised to n multiplied with f dash x dx equals to f of x raised to n plus 1 upon n plus 1 plus c. And it is needless to say that here n is not minus 1. Okay, so because if n is negative 1, so this right hand side will be undefined. So here you can write a note where n is not equal to minus 1. N is not minus 1. So in the first one, what you followed in the first one? The first one you understand. See, this is integrand. What you are integrating is integrand. In the second one, this is integrand. And in the third one, this is integrand. Okay. In the first one, what you noticed? You noticed that numerator is derivative of denominator. So you will write the integration as log of denominator. Here what you noticed? You noticed that in denominator you have square root of a function. In the denominator you have square root of a function, and the numerator happens to be its derivative. So the answer is 2 root f of x. And here f of x raised to n into f dash x. Like you have a function of x, and that function of x has certain power, but it should not be negative 1. Okay, so some function of x has certain power, and you have here the derivative of this function multiplied. So the answer will be, the integration will be f of x raised to n plus 1 upon n plus 1. Now using this, let us solve few problems. I am working on right now from the textbook, that is Maharashtra State Board textbook, exercise 3.2, exercise 3.2, okay, portion A, and first question. Okay, this is on page number 110. This is page number 110. So here it says integrate the following with respect to x. The question reads integrate the following with respect to x. Okay, so here I have the first question. Now the question is log of x the whole raised to n, log x the whole raised to n. I'm doing the first one. Okay, so this is Roman 1, Arabic 1. Okay, so in this one we have total 25 questions. Okay, here in this we have 25 questions. So the first one is log of x the whole raised to n upon x. Okay, I have to integrate this with respect to x. Integrate the following with respect to x. This is the first question. So what I do, students, see, when I'm asked to integrate, I will write integration and then dx, integral sign and dx. Okay, why this dx? Because it is with respect to x. Okay, fine. So what is my integrand here? This is my integrand, the one which I am supposed to integrate. Very good. Now what? Now what? I will write this as I. I write let I equals to, always something which I want to integrate, I write integral with dx, and then I write that as I. It is my assumption that this is I. I is for integral. Okay. Okay, fine. Now students, as you all know that integrating any given function is all about applying results. Okay, applying the results, okay. Integrating is nothing but applying the results. Okay, now see, so far what results we have. We have the list 1 results. Do you remember that? If you don't remember, go to my first video on integration. We have list 1 results, then we have list 2 results. Okay, we have list 2 results. What is list 2 results? In the list 1 results, wherever x is there, we replace that by ax plus b, and we have list 2 results. Then what? Then we did the third list. The third list was what? The third list was the corollaries. You understand? Yes, you can call this as third set of list. Okay, the corollaries and the integration of remaining 4 standard trigonometric functions. Integration of 4 standard trigonometric functions. What do I mean by that? Yes, integration of tan of x, integration of tan of x. When could I do integration of tan of x? I could do integration of tan of x only after we had done this result. Integration of tan of x, integration of cot of x, integration of sec x, integration of cosec x. So all these functions so this is my third list. We can call this as list 3. Okay, so remember students, if you want to integrate a given function, it's all about the application of the results. Okay, so fine, now I understand that what I need to do. So see here, I want to integrate this integrand, so I will be applying the results. Now see, how do I apply the results? I write integral, then I write log x the whole raised to n into 1 upon x dx. Okay, what I did students, very simple. Log x raised to n upon x, I could write this upon x as into 1 upon x. Okay, and then what I notice that here I could apply a result. Which result I can apply? You can check. See, it is this result we are going to apply. Everybody see here. Okay, it is this result we are going to apply. I'm talking about this result. You see this? Yes, f of x raised to n into f dash x log x raised to n, and this is what? Derivative of log of x. If this is log x, the f of x, then this is derivative of log x, that is f dash x. Okay, so this result is applicable. So here I will have to write what? I will have to write using remember students, you use any of these results, you will have to write the result there, using integration of f of x raised to n into f dash x dx equals to log of I'm sorry, equals to f of x raised to n plus 1 upon n plus 1 plus c. We get, what do you get? You get here I equals to, so you get I equals to, the final answer is log of x raised to n plus 1 upon n plus 1 plus c. This is answer. Okay, remember students, all these videos are useful for you only when you learn them, and whatever is there on the screen, okay, whatever you see, you write this all in your notebook, you practice all the problems which I ask you to practice, or else you just keep watching. It is of no use. You have to practice. Okay, so having done question number 1, now I am going for question number 8. When I will have solved this problem, when I will have integrated this function, a lot of problems could be done based on this. So I begin with, I write let I equals to, and the function that we have to integrate is e raised to 2x plus 1 upon e raised to 2x minus 1. Okay, so see here students, I need to integrate this function. What is integration all about? Very simple. If I have a function with me, which is this function, okay, and I want to integrate this, it means simply I must apply some results so that I can get integration of this result, this function. So, but I understand that I don't have any ready-made result for this. I don't have any ready-made results for this. So what do I do? Now I go for transformation. Well done. I go for transformation. What is that? When I notice that I am unable to apply the result, then the given integrand, then the given integrand, I transform. I transform. That is, I put it in some form where the result could be applied. So that is known as transformation. Okay, so let's go ahead. So see here, student, what I write, it is e raised to 2x plus 1, and here down I have e raised to 2x minus 1. So the next step I write is, see, in the denominator I have e raised to 2x minus 1, so the numerator I write e raised to 2x minus 1. And since I wrote this minus 1, see, numerator was not minus 1, it was plus 1, but I wrote negative 1. So if I'm writing negative 1, I will have to write positive 1. Why this positive 1? Because I wrote this negative 1. Okay, yes. So this part is for, this part is, you can say, this is extra, this was not there, I brought in. Okay, so in the numerator, I did not have this part, I brought in. Okay, so but then plus 1 was there, so now I write plus 1. I write plus 1. Okay, so here I write plus 1 and dx. So everybody see, you have e raised to 2x plus 1. So I have here e raised to 2x plus 1. Only this thing I did, which is manipulation. Now why I am doing it? It is for applying the results. I want to transform this. Okay, now students, having done this, see what I will get in the next step. In the next step, now I write e raised to 2x minus 1 in one bracket. Okay, and this is plus 2. Plus 1 is plus 2. Plus 2 I write separately. And here you have e raised to 2x minus 1. Now see what will happen in the next step. The next step, the given denominator, I'll be splitting. I will be separately dividing the two terms by the denominator. Okay, as you all know, students, if you have a plus b over c, then you could write this as a over c plus b over c. That c could be split, right? So here I am splitting this denominator. So this will get me e raised to 2x minus 1 upon e raised to 2x minus 1 and plus 2 upon e raised to 2x minus 1 and dx. This is what you will get. Now what will happen, students, here? This will cancel. See, this cancels with this. Okay, so then I get here I get here I equals to integral 1 plus this. Okay, integral 1 plus 2 upon e raised to 2x minus 1 dx. Now see, students, this is something we are getting for the first time. Okay, I will now write separate integrals. I have got integral 1 plus integral this. So I will write separate integration. So I equals to integral 1 dx plus integration of this thing. Okay. Now here I write 2 out. So I will get integral 1 upon e raised to 2x minus 1 and dx. Okay. So I know integration. See, I know integration of 1 dx, but this integration of 1 dx is from the list. I know the list in which I have integration of 1 dx, but I do not have this in my list of results, 1 upon e raised to 2x minus 1. So what I will have to do? So students, I will once again go for transformation. I need transformation here. Okay, so see, what do I do here? I will write here. Okay, now let me say something here, which I think you know, the chances are very less, but then few students might think it that way. So I don't want any student to think it that way. So I am saying, you know what? Some students say d by dx of e raised to 2x minus 1. Some students will think d by dx of e raised to 2x minus 1. This is derivative of e raised to 2x is e raised to 2x into 2. I'm differentiating the denominator. What is derivative of e raised to 2x minus 1? Derivative of e raised to 2x is e raised to 2x into derivative of 2x 2, and derivative of 1 is 0. So minus 0. So the students will think that derivative denominator is 2 times e raised to 2x. Okay. Now they will think that this 2 we have here. So write this 2 inside. Okay. Written. I write this 2 inside. Then what they will do, they will think, see, this is very rare, but I don't say no. There are students who might think it this way. Okay, then they will, they will say 2 e raised to 2x is the derivative of denominator. 2 e raised to 2x is the derivative of denominator. So since we already have 2 here, so the only thing that we need to do is what? Multiply e raised to 2x. Multiply e raised to 2x. Okay. And since we are multiplying e raised to 2x, so we will divide by e raised to 2x. So they will divide here by e raised to 2x. And then you know what? They think that now they have got the result. Which result? Which result? They think they have got the result f dash x upon f of x dx equals to log of mod f of x plus c. They think they have managed to integrate. But my dear students, this is wrong. Remember, this is wrong. Why wrong? Why wrong? It is wrong because you are not allowed to take any variable. You are not allowed to take any variable outside integral sign. You just cannot multiply a variable and divide by variable. You know what? This way you are taking e raised to 2x outside integral. This has got x. It is not allowed. You cannot do adjustments like this. You cannot have a variable outside integral sign. You cannot have anything in x outside integral sign because you are integrating with respect to x. That way, if you keep doing like this, then at the very first place, why not take this whole thing out? You understand what I'm saying? That in the very first place, you could have taken this itself out. So all the problems, whatever function they give, you take it out. Now here in this, the one that you integrated, this also, why integrate? Take it out. Take it out. This is not done, my dear students. It is against the rule. You cannot take any function of x outside the integral sign. Yes, you can take a constant outside the integral sign. That is allowed. You can take a constant outside the integral sign. Okay. So I hope whatever I said you all have followed. In case if you have a doubt, you can always write it in the comment box. So here I'll have to write this part once again because I have messed it up. So here, see, it is 1, and then see integration of this. 2 is a constant. So I will write 2 out and 1 upon e raised to 2x minus 1 dx. E raised to 2x minus 1 dx. Okay. How do I integrate this? See, this is integration of 1 is x, which I know. Integration of 1 is x, which I know. Integration of this, how do I do it? Okay, since I will not be able to integrate this in the next very step, I will not integrate 1 as well. So I will just keep writing this. So because we have to integrate all at once. So 1 dx here I will write. Or in case if you add, then you will have to write plus c1 plus c1. Okay. So here I write 2 and see how do I do it. I write this as e raised to minus 2x and e raised to minus 2x in numerator, e raised to minus 2x into e raised to 2x minus 1. Okay. So, students, what I did here, I multiplied e raised to minus 2x up and down. See, this is allowed. Why? Because I am not taking it out. Whatever I did, this has got x in it, This has also got x in it. It is all in between dx and integral sign. This is allowed. So let me tell you all once again what I did. I multiplied e raised to 2 e raised to minus 2x up and e raised to minus 2x down. So if you all are amazed that why did I do this, you will know in a while. So just be patient. So here integration of 1, I will still not write because I still do not have the integration of this 2 times, and see here, this is e raised to minus 2x, e raised to minus 2x, and you know students, this e raised to minus 2x which you have in the denominator, this will get multiplied inside in these two terms. So when you multiply e raised to minus 2x with e raised to 2x, you get what? You get e raised to 0. The powers get added now. E raised to minus 2x into e raised to 2x, that is minus 2x plus 2x. So you get e raised to 0, which is 1. So what you get here? You get 1 here. Okay, you get 1 minus, and here what you get? E raised to minus 2x into 1 is e raised to minus 2x. Okay, see students how I manipulated. Okay, see now this 2 I will write inside. So integration of 1 dx plus I will write this 2 inside. This 2 I will write inside. So here I will get 2 times e raised to minus 2x, 2 times e raised to minus 2x, and 1 upon 1 minus e raised to minus 2x dx. Okay, now I want you all to check the derivative of denominator. Now it is time we check the derivative of denominator. So for checking, here I write, see here, let me check d by dx of, see as such this is very simple, you know, this we should know orally. 1 minus e raised to minus 2x. Okay, what is derivative of 1? 0. Then you have this negative sign, put it. What is d by dx of e raised to minus 2x? E raised to minus 2x into derivative of minus 2x, which is minus 2. So what is it? It is negative, negative, positive. So you get 2 times e raised to minus 2x. So see here, what you got? You got derivative of e raised to minus 2x. Derivative of 1 minus e raised to minus 2x is 2 times e raised to minus 2x. So you could say that derivative of denominator is present in numerator. Okay. So what you will do, you will write using, you will now use the result. Using which result? F dash x upon f of x dx equals to log of mod f of x plus c. So you will get the final answer. What will be the final answer, students? It will be I equals to x. I equals to x plus log of mod of 1 minus e raised to minus 2x plus c. This is final answer. I hope you have understood. Pause the video and copy it. So I shall now tell you one more method. This is one method of integrating the given function. I shall tell you one more method. You can say, you can call this as second method. Second method for integrating the same function. Okay, so the second method will proceed in this direction. So see what I do. I write here dividing numerator and denominator by e raised to x. See students, what I'm doing, I'm dividing numerator and denominator both by e raised to x. So what I will get I equals to, see you get here e raised to 2x plus 1 divided by e raised to x, and e raised to 2x minus 1 divided by e raised to x, and here outside here you have dx. Okay, I hope you all have followed it. Okay, so what will be the next step, students? The next step will be, then the next step you will have is I equals to, see this e raised to x, this e raised to x I will split. So e raised to 2x upon e raised to x plus 1 upon e raised to x. So it will get me in the numerator, it will get me e raised to 2x upon e raised to x is e raised to x, and here plus 1 upon e raised to x, that is plus e raised to minus x. Okay, how I got e raised to minus x here? See, when I split the denominator, I have here e raised to 2x upon e raised to x. So this will get me e raised to x, which I wrote here. Then I have plus sign, and here 1 upon e raised to x. This will get me, this will go up e raised to minus x, which I wrote here. Okay, so I have followed. In case if you have any difficulty, you can write and you can work on it, you will get the same thing. And down here what I get, students, I get e raised to x. When I split the denominator, I get e raised to x minus of e raised to minus x. Okay, and then my dear students, look at the denominator. The denominator, if you work on and you differentiate the denominator, you will get here, when you differentiate the denominator, see here the denominator is, let me differentiate this denominator. So d by dx of e raised to x minus e raised to minus x. D by dx of e raised to x is e raised to x. Then I write this negative sign here as it is, and I differentiate e raised to minus x. What is d by dx e raised to minus x? It is e raised to minus x into derivative of minus x, which is minus 1. So it will be e raised to x plus e raised to minus x. So see, when you differentiate the denominator, you get this, which you notice, you get this, you get this, which you notice it is there in the numerator. So what do you understand? You understand that you can use the result. Which result? F dash x upon f of x, the one that you used here. F dash x upon f of x equals to log of mod of f of x. So that result when you use, you will get I equals to log of mod of e raised to x minus e raised to minus x plus c. E raised to x minus e raised to minus x plus c you will get. Okay, this is the final answer. This is the final answer. I know what you all are now thinking. You all are thinking that if earlier method gave us this answer, if the earlier method is giving us this answer, then how come this method is giving us this answer? Because see, they are looking different. Okay, so this is a part of assignment for you. I tell you students that this answer and this answer both are same. It is part of assignment for you. You will have to tell me that how these two answers are same. Write in the comment box. Thank you. So students, now having done that question number 8 by two methods, we'll go for the 10th one. I write let I equals to integral 1 over 4x plus 5 times x raised to negative 11 dx. Okay, so I want you all to try this. Pause the video here and try this, and come after you will have solved. Okay, I hope you all must have done it. See, how do we solve this? What I will do is 1 upon 4x plus 5 upon x raised to 11 and dx. See what is happening here. I told you students, every single time you have to remind yourself that integration is all about applying results. Integration is all about applying results. So when I see this integrand, I have to think of a result which I can apply. So ready-made results are not applicable here. So I am going for transformation. So I will bring in some form for this where I could apply the result. So x raised to negative 11, I wrote 1 upon x raised to 11. Then the LCM in the denominator will get me x raised to 11 here. So this will become 4 times x into x raised to 11. That is x raised to 12 plus 5. And the numerator is 1 here. Okay, numerator is 1 here. So next step, I get I will get here next step as I equals to. Now what happens next? As you all know it. If you have 1 upon a by b, so this b goes up and it becomes b upon a. So the same thing happens here. This x raised to 11 will come and it will multiply this 1. So you will get x raised to 11. You will get x raised to 11 upon 4 times x raised to 12 plus 5. Okay. Now what you can do is you can differentiate the denominator. Okay. So the question here is whether I should be differentiating here itself and make it the solution, part of the solution, or I do it separately. My dear students, this is so simple. You know, this we can differentiate orally. 4 into x raised to 12. What is derivative of 4 into x raised to 12? 4 is out because it is a constant, and derivative of x raised to 12 is 12 into x raised to 12 minus 1, 11. So this is 48 x raised to 11. See, derivative of 4 x raised to 12 is 48 x raised to 11. And what is derivative of 5? Derivative of 5 is 0. Okay. So what is d by dx of, what is d by dx of 4 into x raised to 12 plus 5? You just saw derivative of 4 into x raised to 12 plus 5 is 48 times x raised to 11. Derivative of this is 48 into x raised to 11. But what we have in numerator? We have only x raised to 11. So what I will have to do? I will have to multiply 48 here. And so if I multiply in numerator, I will have to compensate it by multiplying outside. So the next step I will get here 1 upon 48, so that I can multiply 48 and x raised to 11, and here you have 4 into x raised to 12 plus 5. Okay, having done this, I will write using, now since I see derivative of denominator in numerator, so I write using integration of f dash x upon f of x dx equals to log of mod of f of x plus c. Therefore, we get what we get, students. We get I equals to 1 over 48 log of mod of 4x raised to 12 plus 5 plus c. This is answer. I hope you all must have understood. So next question we solve is number 14. Let's take one more question here. 14. This is let I equals to x minus 1 the whole square upon x square plus 1 square and dx. This question is quite interesting. See, how do I manage to transform this? That is, how do I manage to write this given integrand? How do I manage to write this given integrand into a form where I can apply the result? Very simple, students. Integrating any function, any integrand is all about application of result. I want to integrate this. That's it. I want to integrate this. So if I want to integrate this, I will first ask me, do I have a result here? Suppose I ask you integration of cos x dx. Okay. So if I have to integrate, if I have to integrate cos x dx, so do I have to give so many big lecture over here? No, because I know it is in the list. I have this integration by definition. This is sin x plus c. That's it. So if I have to integrate sec x into tan x dx, so do I have to give you big lectures here? No transformation, nothing. It is ready-made result. It is what? It is sec x plus c. But when it comes to this result, I understand it is not ready-made. So what I will have to do? I will have to transform. Now transforming this, student, is a task, and that you learn only by practice. Okay. So see here, I write here x square minus 2x plus 1 square. I am applying the identity a minus b the whole square. So plus 1 square is 1 upon x square plus 1 the whole square. Okay, so see next step what will happen. Now I I regroup the terms. So regrouping. So I have x square plus 1 minus 2x. I write x square plus 1 in one bracket and minus 2x. And here I have x square plus 1 the whole square. Okay. So, and then here what I do, students, I will split the denominator. So one thing I would like to tell you all, that by solving so many problems, by solving whatever problems we have done so far, you must have understood that splitting the denominator, writing few proper terms in the numerator with a plus or negative sign in between, and then denominator, and then splitting the denominator is a major method for for getting the integration transformation, splitting the denominator. This thing we have also done in the previous few problems. So here what I did, I just tried to get what I see in the denominator. See x square plus 1 the whole square I see in the denominator. So I tried to get x square plus 1, and then I am splitting the denominator. So I will split the denominator, that is I will separately divide. So see what do I get? I will get in the next step, I will get I equals to, I will get x square plus 1 over x square plus 1 the whole square. Okay, x square plus 1 upon x square plus 1 the whole square minus 2x upon x square plus 1 the whole square. Okay, and dx. See this, right? So next step what will happen, students? Here you have x square plus 1, so it will cancel 1 power, because denominator you have square, so 1 power gets cancelled. So the next step I get I equals to, I get here 1 upon x square plus 1. Okay, I'm still left with 1 x square plus 1. 1 upon x square plus 1 minus 2x upon x square plus 1 the whole square dx. Okay, so see now I write separate integration. So I write here I equals to 1 upon x square plus 1. I write this as 1 plus x square. 1 upon 1 plus x square I write, and here dx I'm writing separate integral, minus integral I write here 2x. Okay, I write here 2x, integral 2x upon x square plus 1 the whole square and dx. Okay, so see next step, students. Next step it is I equals to 1 upon 1 plus x square dx. Okay, minus, here this thing I take in numerator. I take this thing in numerator. I write this in numerator. So what does it get me when I write that in numerator? It gets me x square plus 1 raised to minus 2 into 2x dx. See, this is all known as manipulation. Okay, I am trying to write the given form into another. I'm trying to write the given function into a form where I could apply the result. And finally, I succeed. How? I will tell you. Look at this. Look at this one. Look at this one. 1 upon 1 plus x square. Okay. Tell me, students, what is d by dx of, tell me what is d by dx of tan inverse of x? It is 1 upon 1 plus x square. Derivative of this, with respect to x is this. So if d by dx of tan inverse of x is 1 upon 1 plus x square, integration of 1 upon 1 plus x square with respect to x is tan inverse x. Yes, sir. So by definition, can I not write integration of 1 upon 1 plus x square dx as tan inverse x plus c? Definitely I can write. So see, I have integration of 1 upon 1 plus x square. Further, look at this. Look at this. This here, what you notice that you got here f of x. See, you got here f of x raised to n, x square plus 1 raised to n. And if I call this x square plus 1, if I call it as f of x, what is 2x? Is that, isn't that 2x derivative of x square plus 1? Derivative of x square, 2x plus 1, derivative of 1, 0. So 2x plus 0, which is 2x. So here I have f of x raised to n into f dash x dx. What I have f of x raised to n into f dash x dx. So using these results, I will get the answer. Okay, I will get the answer here. So what will the answer be? See students, so the answer I will write as, I write here, using integration of f of x raised to n into f dash x dx equals to f of x raised to n plus 1 upon n plus 1 plus c, we get what you get. I write the answer here. We get I equals to this one. This one will get me tan inverse x. This is tan inverse of x. Okay. Integration of 1 upon 1 plus x squared dx is tan inverse x minus, and here I will get f of x raised to n plus 1 upon n plus 1. So x square plus 1 raised to minus 2 plus 1 over minus 2 plus 1 plus c. So the final answer you get is I equals to tan inverse of x plus, this will get you negative 1, negative 1 will change this sign, it becomes positive 1, and here you will get x square plus 1 raised to minus 1, that is 1 upon x square plus 1 plus c. This is the final answer. This is final answer. Okay, I hope you all have followed this. Okay, practice these questions again and again, the first 100 problems in indefinite integration, if you solve again and again these all ideas, you will start remembering, and then the things will become very, very, very easy for you. Thank you.